Hello and welcome to my video, Conservation of Energy Part 2. So I actually added another question since the end of that last video. So hopefully this one is just one level higher, one more level difficult. And hopefully this can benefit you guys greatly. So just to start with, this is the formula for conservation of energy. So if you have not seen that yet, please watch part 1. But basically, the sum of all energies at the beginning is equal to the sum of all energy at the end. And specifically, we're talking mechanical energy in the case of Physics 20, in the case of our course here. So a loonie is thrown off the top of the 32.3 meter high bungee jump at Wested Park, a water park. If its initial throw gives it a speed of blank, what height does it reach a speed of blank? So basically here at the beginning, it has a height, an initial height of 32.3 meters. It also has an initial velocity of 4.25 meters per second. And so the question is, at some point, whatever that point might be, it's going to have a new height, a final height. We don't know what that is, but it's going to have that final height at the same time that it has the final velocity of 23.9 meters per second, assuming no air resistance. Which is why a loonie is probably pretty good for this, because it's heavy and dense, and so air friction would have a smaller effect on it. Although I would imagine it would reach terminal velocity anyway from this height. So let's go ahead and try this out. So there's actually an initial speed, initial height, a final speed, and a final height. So we have to keep all parts of our equation, but we're looking for the final height. So mvi squared over 2 plus mghi equals mvf squared over 2 plus mghf. Now, I'm just going to write that as HF in a different color to show that's what we're looking for. So we need to use opposite operators, opposite bed mass in order to solve for that unknown. So we always start with addition, subtraction when we're doing opposite operators. So what we're going to do is we're going to subtract by mvf squared over 2 on both sides. All right, so what we're going to be left with is mvi squared over 2 minus mvf squared over 2 plus mghi equals mghf. So now what we have to do is divide by mg on both sides, and on all parts over here, but you'll notice that these will all cancel, so that's good. The m's will cancel over here, so that's good because we weren't even given the mass of a loonie to begin with. So what we're going to be left with is HF equals VI squared over 2G minus VF squared over 2G plus HI. Alright, so at this point, I would just plug it into my calculator, but I'm going to write all of these out for you. 4.25 squared over 2 times 9.81 minus and then 23.9 squared over 2 times 9.81. I'm going to make that square just a little bit higher. There you go. Plus HI, which is 32.3. So, plugging all of this into my calculator, all of it at once. It's always better to do it all at once if you can, if you have a good enough calculator for that. And I do, and I hope that you guys buy a TI-84 plus CE because they're wonderful and they can write all of this in at once. Alright, so this is the height given to me by my calculator. Given that we have 3 sig digs everywhere else, we're going to have 4.11 meters off the top of the water is what that would be. Alright, so that would be the height at which it is 23.9 meters per second. Alright, let's take a look at this last question here. A 100 kilogram ball is dropped from a height of 100 centimeters. It bounces back to a maximum height of 40 centimeters. Determine the gravitational potential energy before the ball was dropped. So the initial, okay, so this is EPI that we're looking for, which would be mghi. So this is easy. We're just going to do our m, which is 0.1 kilograms, times by 9.81 meters per second squared, times by our initial height of 1 meter. 100 centimeters is 1 meter. So, actually that's going to be very easy. It'll be 0.981 joules of energy to start. Okay, and our final position after the bounce, this is going to be energy final, would be mgHf equals, and in this case, well, let's see here. So this would still be 0.1 kilograms. This would be 9.81 meters per second squared. And this would be 0.4 meters because it is 40 centimeters. So 0. So we get 0.3924 joules, which would round to 0.392 joules. So there you go. So what happened to the remaining energy? Well, there's going to be a whole bunch of energy loss in the sound of the ball hitting the ground, as well as the collision imparts a frictional force and a squishing force, and there's going to be all sorts of tensions and forces, and therefore wasted heat and sound based off of the ball bouncing off the ground. So it's actually going to have a smaller height, and this is realistic because the energy is being wasted in the form of heat or sound, most likely. Okay, determine the percent efficiency of the energy transfer during the bounce. Well, what you could notice is that the total energy was this EPI. Okay, and the energy at the end was EF. Well, with that said, the difference between the two is the, or if we divide the two and times by 100, that would be our percent efficiency. So, I mean, we could write all of these in again, or I could write it like this, even better. So HF over MGHI. You'll notice that MG and MG are on top and bottom. And so we're left with 0.4 meters over over 1.0 meters times by 100, which is going to be 40%. So this bounce is 40% efficient in order for it to bounce back to its original energy. So that means 60% of the energy was actually lost due to friction or sound in the system. Alright, I hope this video helps you better understand conservation of energy. You'll notice that in the second example, energy was not conserved because it did not go to the final height. But energy is conserved overall. You just have to remember that energy was lost and given to something else. So heat, or sound, or light, or whatever else. So yeah, I hope this video helps you better understand conservation of energy, and these types of examples make a little bit more sense to you. I also recommend taking a look at my Science 10 playlist because I have a couple good examples on that playlist as well, like a roller coaster question and a pendulum question. Those are the two classics, so please take a look at those two as well. Good luck!